Welcome to DevOps Accents, a podcast on everything around DevOps, public cloud, and cloud-native topics, with your hosts, Pablo, Leo, and Kirill.
Hello and welcome into another episode of DevOps Accent, a podcast where we discuss DevOps, artificial intelligence, data, everything around IT and things that happen at MKDev, around it, and in general, the news that got our attention. And today, we've got a special guest with us, Hanson Ho, How's correctly?
That's correct.
That's correct. Cool. He is an Android architect from Embrace. If you haven't heard of them, Embrace is doing some awesome stuff in mobile observability, helping developers keep their apps running smoothly in real time. Hanson is helping transition their platform onto OpenTelemetry. Hanson has some more than a decade of experience at performance and observability, starting at Twitter, where he was involved with the client tracing platform, and he's applying that experience at Embrace to address the unique problems of mobile observability, which we are going to discuss today. Hanson, great to have you on the show. Welcome. How are you?
Pretty good. Thanks, Leo. Thanks for having me on.
Thank you for joining us today. It is a great pleasure to have you on the podcast. And before we begin, I would like to address an elephant in the room. I'm the only host in the show today because Pablo and Kirill, they're traveling and they're attending a lot of conferences. We've been posting about our recent conferences we've been attended. I share my view on fintech in the recent MKDev Dispatch newsletter. Go and read about it. My observation on fintech. Pablo is traveling in Spain. He was at South Summit, and currently he is at CTO Summit. Very interesting conversation. Summits and conferences. He shared his opinion on that on the video, the most recent video on our YouTube channel. Go and watch it. It's very interesting. And don't forget to subscribe because every 2 weeks we release MK news. And by the time you're watching this episode, I assume there is another episode of MK news. And so, getting back to you, Hanson, and my favorite question to all the guests that we have on our podcast, given the name of our podcast, DevOps Accent, what is your accent?
Western Canada by way of Hong Kong, I guess.
Wow, what a mix. Is it like
so kind of
historically?
Yeah, I moved to Canada when I was 8, immigrated, and been in Vancouver ever since. So I speak English like a Vancouverite. I speak Cantonese like a Hong Konger, except probably with slang that is way past its expiry date. But yeah, if I speak English, most of the time, 99%, it sounds like I'm, I play hockey and ski and stuff, but I don't play hockey and I don't ski.
Really?
No. Outdoors? No, I like indoors. Curling, that's what I like.
Cool. And speaking about your, so to say, professional accents and your professional preferences, tell us a little bit about yourself. How happened that you are currently where you are today?
Yeah, so I think out of school, I joined a company that was eventually acquired by Business Objects in France, and then SAP, doing, I guess at that point, it was called client work. There was C++, Windows apps. There were web apps involving JavaScript back when we called it DHTML, when we made things move on the static web pages. We called it dynamic HTML. For the old heads. And then from there, I went to Salesforce to do a social collaboration platform thing, also on the UI. So most of my work, previously been in UI. And then I went to Twitter and I worked on Android because, hey, Android is Java mostly, and there's UI in Android. So that works. And yeah, it was like interesting challenge. And I got working on a team that focused on performance, especially in emerging markets with slow networks, slow-end devices, things that don't work very well if you have a regular app that has not been tested with such a device in such a condition. So I learned a lot about the Android ecosystem, the variety that you get in Android ecosystems, and some of the strange occurrences that happen when you have devices that constantly get cleared memory and disk space and cache, and how to make that work well. And from there, I kind of became, a bit of rather my focus area, my interest became that of low-end devices and performance. And it allowed me to kind of understand the nuances of mobile as it pertains to performance and expectations.
I see.
Observability came next. And it just became a natural fit. Twitter needed to measure performance of app startup and other critical performance sensitive areas, and I kind of just learned as I went.
So it was more like a choice rather than an accident that you end up in observability area.
Yeah, observability it marries well with my interests. Like I love numbers, metrics, stats. I like advanced analytics in baseball and football and things like that. So professionally, I also work with lots of numbers and stats and trying to optimize and see variables change. So it became a really natural fit. It's a fairly niche area, especially in mobile. When you talk about observability in mobile, you don't see a lot of people who are like particularly interested in this area. And I think I fit. I like it. I like it quite a bit.
Yeah, I think this is a work of passion, like for you exactly. Okay, so this is another accent in our collection of DevOps accents. Thank you for that. And I'd like to go deeper into your experience and discuss this to you. But before we jump into nitty gritty, I'd like to take a moment to talk about observability in general. So we had an episode on observability in the past. If you are interested in learning more, a little bit more, go and watch it before continue here. And I will make sure to have a link in the description. But anyway, in today's complex IT world, observability is like more crucial than ever, I think. So it is not just about keeping an eye on things, right? It's about like really understanding what's happening inside our system by collecting, analyzing all sorts of data. We've been discussing this in the previous episode, and today with Hanson, we will try to learn how the things are on mobile devices, and are they so different, right? So anyway, the goal is to make our system so transparent that we can spot issues before they blow up and fix them fast. But as we all know, that's easier said than done. Speaking about observability trends in 2024, one of the biggest hurdles we face today is rising so-called mean time to recovery for production issues. And even though the companies are investing more in observability tools, the increasing complexity of our environments is making it tougher to quickly pinpoint and resolve problems. It's kind of ironic. The more data doesn't always mean quicker fixes. And another big trend is cost of maintaining good observability. With data volumes going through the roof, companies are trying to manage cost by being smarter about the data they collect. I don't know, like it's balancing act, getting enough observability without blowing the budget. I can only assume this is especially tricky in mobile world, right? Where the data is more fragmented and variable. Is that correct?
Yeah, definitely. It's very unpredictable because of the runtime environment. So you need a lot of data about the context.
Yeah. We can deep dive on it a little bit later. And plus, like continuing on the trends, like even though OpenTelemetry adoption is high, we still see a shift from relying solely on open source tools because of the rising cost and complexity. This points to a move towards more integrated, possibly proprietary solutions. And in mobile observability, the shift might look different because of the unique challenges mobile developers face, like different device performance and network condition. So, Hanson, let's dive deep into these topics. Compare desktop and mobile observability, because I think for our listeners it will be the interesting part, and discuss the possible innovative solution that can be brought to the table. How do you look to that?
So I can't really speak much to desktops because desktops are very similar to mobile, but I can kind of talk about how it differs from the backend observability. So traditionally, mobile observability in the mobile sense is about what they call runtime user monitoring. It's about knowing your crashes. It's about knowing, various things that folks are familiar with in the mobile space, fix problems. Those don't tend to marry well with observability kind of practices, with traces and things like that. So in the recent past, folks have been more focused on performance. So logging crashes and understanding crashes and simply not enough. So they want to kind of bring the idea of observability and observability tooling into the client. But what we face is a different set of challenges, given that we on the client, an app is fairly simple. It's one process generally with a handful of threads. There isn't a lot of variance like a distributed trace you would have in the backend. So some of the tooling designed for context propagation of distributed tracing get a little bit complex when applied to the client model. And frankly, client devs are also, or mobile devs, I should say, are also not come a variety of experiences. So not everybody is familiar with what a thread is. Not everybody is familiar with, tracing context, what a span is, things like that. So when you give them an API, you say, "Oh yeah, you gotta do this and this and this." They throw their hands up and say, "Oh, I don't know. Google gives me these very simple to use API, and I know how to do that. But anything harder is difficult." So just educating the community is not as straightforward as with backend devs. There's just a lot of assumptions that were made for backend observability that just does not apply to mobile. An unstable environment, when you collect the data, it doesn't mean it gets transmitted. If the user goes offline, the data is gone. Data could be delayed. Data could be captured wrongly because an OEM from a different part of the world decided to override a system function that makes things a little different. So the data you get is dirty, and you don't have a lot of expectation in terms of, I expect P99 to run this way because you have a fixed set of hardware you're running on. You could be running on really old devices using really old networking equipment, just so the network gets slow, and you have a lot of unpredictability. So in general, it's just not as solid and stable, the data you get, and you kind of have to prepare for that in terms of your data collection.
I have one particular question, and I'd like to give us more a specific example, because I'm not entirely sure how this works. Because when we speak about desktop observability, it's I understand it better, because with desktop the environment is somewhat predictable, but in the mobile world, as you mentioned, you have the whole new set of challenges, like the variability of network condition, device performance differences, and user interaction add layers of complexities. One of the big challenges, you probably have, is a gap between back-end and front-end systems. Most of the traditional tools out there are designed with the backend in mind, or at least this is what I see from our experience, which means we are missing out on a lot of valuable insights from front end, especially in mobile apps. There just aren't enough standardized conventions on things like user tabs, sessions, and other mobile-specific events. And while OpenTelemetry has made great strides in creating a shared language, it's still very back-end focused, I think. So I'd like to see your thoughts on how these differences impact the strategies and tools you're using for mobile observability, but probably in a specific example that you mentioned a little bit before, that you've been focusing on at Twitter, you've been focusing on emerging markets, because I can imagine if a user is using your application in a country where the mobile internet is so slow, so poor, so you have to throw your phone in the air in order to catch the signal. So, and you cannot get there and test it hands-on. What do you see sitting where you sit today? And how do you understand that this is the particular issue that your customer experiencing?
I mean, this is the key to why production data and observability data from production is so necessary. A lot of times you can't simply reproduce the issue that folks tell you about anecdotally. You want the data, the user experience, to be translated into signals and sent to the server so that we could, understand what is happening. The sequencing of particular events have tremendous impact on what happened. So one of the main use cases of mobile observability tools in the past was user sessions. So you can basically see the flow of what a user goes through when they encounter a crash or encounter a slowdown. So you can basically build up your context. Not only do you know what the runtime environment is, like is your phone being throttled by the OS because it's running on low power, or did you just, start a really intensive, image encoding task right before you submitted your request? That could be taking resources away from your phone. CPU cycles. Again, one process. The app doesn't give you a lot, the OS doesn't give you a lot of room to basically drain all of the cores that are on the phone. They say, yo, we're gonna give you your little sandbox and your little quota of CPU cycles, and you better play nice with it. And having the ability to look at the sequencing allows us to determine what the potential issues are. So, this type of thing, it requires real world conditions. And as you said, I can't just fly to a place with poor networks and buy one of their phones and then try, maybe you might not get it because it could happen once out of every 1,000 times. You have to walk into an elevator before it happens or something like that because of the network transition from Wi-Fi to LTE. Something about that change is causing it. So getting production data is important, but that production data in the past for mobile just isn't encoded in any sort of shared language. And with OpenTelemetry, at the very least, even if we don't have semantic conventions quite yet defining what a crash is and things like that, there is at least the notion of a trace of a span of a log that you can understand and match up and use the same tooling to kind of parse and understand. So that's a huge step moving to OpenTelemetry and a shared language for mobile.
Just while you were talking, I remembered. So when I have my device, and almost the first thing that I do with it, I deactivate all the send usage data to anyone. Like, do I prevent you from understanding what's going on when I have issues?
Generally, no. It depends on so on mobile. Another funny thing is, and I mainly speak from an Android perspective. iOS is a little different world. There's a lot of different ways to get data about performance and runtime. Google's done a really good job of locking down PII, so we can't uniquely identify a device and things like that. So no matter what we do, we're not going to be able to get really sensitive information. But in terms of trying to get when the process started, how a crash happened, there are a number of ways of getting to it. And generally, observability tools don't So what you're disabling in general, I believe, is as data sent to Google, so automatic crash reporting, things like that. We don't use. So Google is very interesting in the sense that they collect a lot of data, but not a lot of those data is available to developers.
Okay.
So we have to use different means to basically try to obtain the same data through instrumentation, through reading certain outputs. So as a feature of not exposing their data to us that you're saying don't send to them, it means that we have to go around it anyway to get the data. So short answer is no, we could probably still see your crashes even if you disable the automatic crash reporting to Google, because we look at it differently. Mm-hmm. Thanks, Google, for forcing us to do that.
Yeah. One of the critical challenges in the observability space today, based on what I learned from our past experts we've been talking to, and from my general understanding, is the rising mean time to recovery, MTTR, for production incidents. So despite the proliferation of advanced observability tools, the complexity of modern IT environments is making it increasingly difficult to identify and resolve issues quickly. And the paradox here is that while we have more data at our disposal than ever before, this hasn't necessarily translated into faster recovery times. This growing complexity can be attributed to several factors, like modern IT infrastructures are composed of numerous interconnected components, cloud services, microservices, containers, blah, blah, blah. Each of these generates a vast amount of data. And correlating this data to pinpoint the root cause of issue can be like, I don't know, like finding a needle in a haystack, right? And additionally, the lack of integration between different monitoring tools can create fragmented views of the system you're dealing with, making it hard to get a comprehensive understanding. And in context of mobile observability, I think these challenges are even more pronounced because, like, how I understand this, like the mobile environment, they have layers of variability that you mentioned, and this variability means that mobile observability tools must be exceptionally robust and adaptive to provide meaningful insights to you. So, Hanson, from your experience at the Brace, how does the complexity of mobile environments impact MTTR? And are there like strategies or tools that you are using or you are developing or you have in mind that have proven effective in reducing recovery times in such variable condition? Without breaking your NDA, of course.
The cloud tech industry is evolving so fast. Do you keep up with it by improving your skills or upskilling your team? At MKDev, we offer a variety of workshops for just that, from the basics to expert knowledge. Before delivering our workshops and training sessions, we carry out a detailed assessment of each participant. To make sure the workshop is helpful for you and your team, we will add more content to it or throw out what you already know. Or we create a custom workshop specifically for the needs of your team and the specifics of your project.
So we can always talk about this in two segments. One is if the issue actually happens in the mobile app, or if the issue is actually something that is on the back end. So let's talk about the mobile app first. I think, traditionally observability tools in mobile is designed to find the needles in haystacks. We don't look at P99.9. We look at, specific instances of crashes because we are trying to find needles in haystacks because that's generally the thing that production data helps us with. So strategies to kind of prevent those from becoming a big issue is actually not with observability. It's more with your rollout practices, because typically bugs occur when we upgrade versions. Obviously, a new version has tons of changes, and those changes could have unintended circumstances or consequences when released. So typically what folks do is they do a stage rollout. So they do 1% for 24 hours, see that there aren't major problems, and then roll it out, the rest out. And if there are particularly challenging features that may be buggy, it's put behind a feature flag so that it could be disabled in production. So doing those two things is already I wouldn't say good enough, but if you're not doing those two things and you're seeing mobile bugs, you should start doing those two things, because it'll catch most of the really challenging and obvious ones. If something happens in a very, very small isolated circumstance that 1% won't catch, well, by definition, it's only a small number of people. So it's probably less impactful than a crash that affects, 10% or 20% of your users. So that's on the mobile side, and observability, traditional tools are fairly good at kind of finding that. But on the backend side, you're right. Adding more traces to complex microservices tells you more about the internal state. But how much marginal utility are you getting when you already have a lot of traces? When you bring in the mobile data and you're able to connect the mobile data to the backend, you can start seeing things that perhaps you're not capturing on the mobile or on the backend side. Maybe the particular details of a payload of a request is too large to actually put into a log. But on mobile, you can actually link that. You can actually, we do record that because it's done, not as part of the requests, to the backend. And if you have a way of linking your client data with your backend data, you can see the specific requests that generated, the particularly slow trace. That request and that user, you have the context of what led to that. Now, ultimately, what is affected on the back end is what's in the request. Well, you can know the request payload. You can know the request, parameters that you send in URL or headers that you may not be capturing entirely from your front end, your Nginx. Maybe stripping away that data and just basically passing in what you think is relevant to your observability systems, because you mentioned volume being a problem before. Well, you don't want to capture everything, right? Mm-hmm. It's too expensive. Yeah. But if you have mobile observability, it captures and puts it in a different system. You can then link the two sets of data and get additional context. So instead of trying to find a needle in a haystack, you're looking at it from a totally different perspective. You're using a metal detector, so you don't have to use your eyes. You're using another technology, giving you more context. So in terms of MTT. On mobile, well, you have to wait for the App Store to release your thing, your new update. So generally, it's not a fantastic metric for us. But on the server, it can give you more data and more context and help reduce something that you could fix on the server side.
Okay. You mentioned cost that can be increased drastically, and I think this is another significant challenge in the realm of observability. As data volumes increase, so do the expenses associated with storing, processing, analyzing the data. And I can assume organizations are being forced to rethink their observability strategies to manage cost effectively while still maintaining comprehensive coverage. One approach that I know, to managing this cost, is by optimizing the volume of monitoring data collected. Instead of collecting everything, you can collect only the thing that you are interested in. This involves being more selective about what data is captured and stored, focusing on the high value telemetry that can provide actionable insights. However, this can be a double-edged sword, as I see this. Reducing data volume might mean missing out on critical information that could be key to diagnosing and resolving issues. What do you think about this? When we create this kind of approach, how companies can be sure that they are not missing the data, and how they can learn about the fact that some data is missing? Like, is there a tool for that? Is there a signals for that? Or like you have to call, I don't know, an Oracle?
Well, hopefully not Oracle, if you're talking about costs. So this is a really interesting question. Folks are complaining about large Datadog bills because, well, they're just basically storing data in large volumes because you're collecting tons of logs. And you know, the first strategy of managing that is, well, we'll delete some, we'll delete the old ones. But what you're doing is, as you said, you should be deleting important context just because the data that you collect is necessary for you to debug. So if you're deleting it, you know, how are you going to do it? Well, I guess you have a shorter time period to debug, and that's one way of doing it. But I think you only get incremental gains when you start doing that type of, you know, nipping and tucking on the edges. What's important is be more efficient about the data you collect and how you collect it and how you store it. Like, what are you collecting? Are you collecting really verbose logs that you need to you know, in Splunk that you need to, you know, process a lot just to get data with, you know, text searches? Are you doing things? Are you collecting data in such a way that it's easy to imbue context for transformation? Are you collecting structured logs? Are you collecting wide events with lots of context, lots of dimensions, so you can actually do filtering and grouping on this handful of events by changing the context? So there are probably smarter ways of collecting and storing data. I think that's one aspect of it. Another is if you're locked into a particular vendor and their proprietary platform, you're basically saying, well, if my alternative is to move off of you and migrate to a different system, and you know, migrations are very, very expensive and very, very, you know, problematic. I mean, it may be good for MK Dev, you know, consulting and helping folks with that migration, but you know, as a you know, holder of a budget, you don't want to do migrations. As you know, back-end developers, you don't want to do migrations unless you have to. So having a standard that makes it easy to migrate from one vendor to another. If your data is collected in an open standard and your data is processed by an open standard, it is much more attractive to say, well, if this vendor's charging me too much, can I move to another vendor and basically do a migration? But the migration is a lot smaller. The data is the same in terms of shape. I'm just paying a different person to process it. So OpenTelemetry allows us, or you know, folks with choice to say, you know what, I don't have to go with Datadog or New Relic or any one of these big guys with, you know, a full suite solution. I'm OpenTelemetry, so I could move to other vendors that understand OpenTelemetry and process OpenTelemetry and collect OpenTelemetry. So not only is shifting what you collect important, but how you collect and what you store it as is also really important for managing costs going forward. You're not beholden to your one vendor. That would be very expensive to get off of. You're basically say, hey, the entire community, what do I have?
Is OpenTelemetry is a way of standardizing telemetry data? Like, is this one of the solutions? Yeah,
OpenTelemetry, it defines a protocol for defining traces or spans and logs and metrics. Has SDKs and APIs on many different languages, and a collector interface on the server to ingest the data and process it. So it is a definition of an open standard that goes, you know, from nose to tail, or nose to tail, in order for you to set up observability. So it is a standard. So it doesn't exist as a commercial product. So you can assemble it yourself, take the pieces and put it together yourself. Or there are a handful of vendors that support it, like Grafana, Honeycomb, many other vendors that collect data in OpenTelemetry, send data to you in OpenTelemetry, so that it works within the ecosystem. So you talked previously about reducing IT costs by standardizing on a vendor. Well, not all vendors use proprietary platforms. Many use OpenTelemetry. And if you are on a vendor that is using OpenTelemetry, it is much easier to switch to another vendor that is on OpenTelemetry. And you can start bringing in pieces because we all talk the same language. So, the theme of the podcast, DevOps accents, we may speak with different accents, but we all speak in English. And when we're talking, so we understand each other. So mobile might be a Portuguese accent, but English. Backend may be an American accent, East Coast, in English. It sounds different, but they use the same words, and it's much easier to understand. And OpenTelemetry offers that as a means of giving you an option of reducing costs.
But isn't there a shift towards integrated solutions? I understand organization initially turning to open source solutions like OpenTelemetry for their flexibility. But as the complexity and cost of maintaining the solutions grow, they might be interested in shifting towards more integrated proprietary solution. And I don't entirely understand how to balance this. While open source tools offer a high degree of customizations, they often require significant effort to integrate and maintain, if I'm correct at all. But on the other hand, proprietary solution, they can provide a more cohesive and user-friendly experience, but you have to spend a lot of money into creating, maintaining this your own solution. So, on your experience, if this move towards integrated solution, observability solution is a thing, and if it's impacting the mobile development landscape, do you see a preference in the development community?
Yeah, I think actually the integration part does impact mobile because mobile is not typically seen as a driving force in observability tooling. Back when, money was cheap and, the wine was flowing, you can have budget for bespoke mobile tools that help you solve mobile problems in ways that the mobile team wants. But when budgets kind of reduce and you already have Datadog as a backend vendor and say, Datadog, here's a mobile solution. You can have it for free for a while, or here's a discount. As the holder of the purse strings, it's much easier to say, yeah, we're gonna cancel your contract with your bespoke vendor and just use Datadog. Even if Datadog's solution isn't great, it exists, and there are many free solutions too. Like Crashlytics is free, Firebase, I should say. So there are ways of getting mobile data cheaply in an integrated way. So that has definitely impacted on the mobile side. But just because there's an integrated solution doesn't mean it has to be a proprietary format. You can have integrated solutions from a vendor that is based on open source standards and software, like OpenTelemetry. So you're not actually giving up the integrated solution. You're just choosing one where the data is in an open format. So it is portable. You're not locked in. So if you use Honeycomb, if you use Grafana, they'll give you a full stack solution. But you could also plug in Embrace because we talk OpenTelemetry to provide you mobile data. You're not beholden to whatever your proprietary vendor gives you for mobile. Because if everything is OpenTelemetry and we all send it to the same collectors, it's the same language. We're using the same words. So which is why you can augment your full stack solution with something that is, maybe a bit more suited to what your mobile team needs without having it be incompatible because of OpenTelemetry. So OpenTelemetry is actually a way of improving your integration experience, an integrated solution experience, by giving you more choices to not pick the one that you have to offer every single thing you want. As long as it offers 90% of what you want, you can start adding other pieces in there to increase the effectiveness of your integrated solution. So it's actually working towards the trend, I think.
Cool, because you already answered the question that I wanted to ask about, like if this is what's happening at Embrace, and apparently it is.
We were recording data in a proprietary format merely months ago, but we recognize that open source, open standards is the way, especially on mobile communities. So we made a hard pivot towards OpenTelemetry and really embraced it because we think it's the future. We think it's the second most popular project in CNCF behind Kubernetes. It is in and of itself a trend, and talking in a language that other people understand makes it more appealing, especially when we're talking to SREs and backend observability folks who traditionally don't think about mobile, but now are starting to think about, hey, you know what? A lot of these requests coming into these backends, they're from mobile apps. So maybe we should have some observability tooling in there that reports data in a format that we want, and that can be merged and matched up with our backend data. And Embrace is right there, but Embrace is not the only ones. It's an open standard. Anybody could build a client or an SDK for it. We just like our SDK.
I imagining the developers who are listening to us right now, like this is Hanson calling you guys, switch to OpenTelemetry, like be more transparent, be more easy to understand, so that you could be more effective. Because if we start speaking the same language, even if it's a different accent, it would be easier for us to understand. Is it the way is it the correct way how I understand your message? You're nodding, but
yeah, no. It is. So mobile teams tend to be siloed in large organizations. They tend to work differently from the back-end teams, and they don't talk. They use different tooling. Like I said, RUM tools traditionally are recording things in proprietary formats. That data is not linked with back-end data. With budgets consolidating, these teams need to talk for budget reasons, if nothing else. But also when they start talking and when the data starts to kind of be merged together in interesting ways, you get more information from the back end, for the back end, by getting more context. You actually understand more about the requests coming in causing the issues. So that's why SREs are beginning to pay attention to mobile devs and mobile tooling. And that's why mobile tooling users are beginning to understand that, hey, maybe if we actually store and get our data in a format that the backend understands, they can actually give us the budget to get the tools that we need to do our problems, rather than begging for scraps, in this challenging macroeconomic environment. So this is beneficial to mobile devs.
All right, Hanson. We've been talking about like the landscape of observability is constantly evolving, like shifting, and looking ahead, what are some of the future trends in observability that you're excited about? While preparing to this podcast, I saw like a number of names, and like for example, there have been a lot of talk about the shift from observability 1.0 to 2.0. What is that?
So I believe Charity Majors, who's the CTO for Honeycomb, coined that. Or if they didn't, apologies. Somebody did. That's who I heard it from first. So 1.0 tends to be about your traditional observability data signals collection, logs and traces and metrics, the quote unquote 3 pillars. You collect lots and lots of them. But they don't have a ton of context. So you have to kind of store lots and lots of them in order to get the data that you need. It might be hard to group by hard cardinality data, dimensions, and things like that. But you collect a lot of data in order to get what you need.
Yeah.
2.0 is a shift in what I was trying to talk about previously, of collecting data more smartly, collecting wide events, structured logs that you could process that has a lot of high cardinality dimensions attached to them, or rather a lot of dimensions that give context attached to them, some of which may be high cardinality.
I see.
And through the variations and the permutations of these attributes, you can glean insight without having to capture a ton of events. So what you're giving is you're collecting fewer events, I guess, but with more context. So you could transform it in novel ways. So I don't want to. I'm not equipped to speak to the details of this. There are many good books out there. Charity's written book, Observability Engineering on O'Reilly. You can pick up lots of blog posts out there about this. But it's really about wide events, collecting data and events with context, and transforming it in a smart and fast way in order to get your insights. So you can answer the unknown unknowns and not simply record traces for problem areas or known areas of problems. So it's about being proactive rather than being reactive, and collecting data with context, events with context, and not just writing tons and tons of logs, onto disk and hoping that they contain the information you need.
How does your ideal future look like? Because I understand you are sitting at your desktop working daily and you think, I wish we had that, or I wish we had this, because, more and more news recently that I read, that I think it's getting us closer to the future that we saw on the movies. Like, for example, the recent successful tests of a phone that connects directly to Starlink, for example, right, without additional antennas, without additional devices, like directly from phone to the satellite. How cool is that? And I can imagine you sitting there and you hear, I wish all the devices were the same. Or I wish we could store all the data in the world. I have limitless data centers, and it was okay, describe me your future.
My ideal future is a lot easier to achieve than that, I think. So I really just want us to talk in the same language in a rich way that isn't rooted in a particular perspective. So OpenTelemetry, great as it is still built for and by and predominantly used by backend distributed tracing folks. And there are just certain things about it that I think don't fit super nicely when we switch it to the mobile context. So my ideal future, which I'm hoping to be part of to help push it forward, is that the API and the data models become a bit more friendly to mobile use cases. So that developers who are on Android or iOS or React Native or Flutter or Kotlin multi-platform have easy access, an easy gateway into, oh yeah, I look at this SDK and it looks like it's for me. It looks like it's designed with me in mind as a Kotlin developer, and be able to kind of record data and have that seamlessly go through the architecture and the infrastructure to the back end and have it merged, and have concepts on the client like sessions be represented as a first class citizen rather than just an attribute on a signal. So these are I would say they're not big asks or big requests. They're simply, I think, natural evolutions as use cases are introduced. It makes sense to OpenTelemetry's focus on the back end because that's who was using it. But now that more folks are looking at it from different perspectives, I'm pretty sure that the spec will evolve in order to accommodate the other use cases, to make it less server centric and more computing centric. It works for different use cases. That's my hope.
Yeah. So this is basically a ready to go task for a lot of us, and for you who've been listening to us today. Go and implement, because you know how to do that. You've been Hanson just explained to you what you need to do. This is a task for you. Go solve this problem. And speaking of which, for those who would like to know more about OpenTelemetry, about the issues, Androids, how your work, where they can find you, how can they connect with you, learn more from you, where you inhabited?
I mean, if you're interested in OpenTelemetry, I would sign up for the CNCF Slack, and go to some OpenTelemetry channels and start learning. They have lots of documentation, OpenTelemetry.io, about the standard. If you want to learn about Embrace and kind of what we're doing, Embrace.io is our website, and you can find us on GitHub. All our SDK or our iOS and Android SDKs are open source completely. So you can look at the code, feel free to fork and do as you will. Open source is open source. So, feel free to do whatever you enter issues to contribute. I think getting in part of the community is the most important thing. If you want to kind of get it on the ground floor on this stuff. OpenTelemetry is a very welcoming and friendly community with lots of special interest groups that look at particular niches and spaces in OpenTelemetry. So I would definitely urge you to check that out. For me, I'm not that interesting, but you can find me online. I'm fairly idiosyncratic. If you put in my name, there's only one Android person in North America. There's an architect in Singapore too, but Hanson Ho is not a widely name. So
I will make sure to have all the links in the description, just for convenience. And thank you, Hanson. And thank you for joining us today and being a part of DevOps Accents. It was very interesting. And I hope those who were listening to us learned a lot of new things. Make sure to give us a likes, send your questions to the comment section below, or reply to our MKDev Dispatch newsletter with your email, with your thoughts, and we will make sure to address them. Again, Hanson, thank you for being with me today. It was a pleasure having you.
Thanks, Leo. This was fun.
Bye, everyone.
There are no challenges that we couldn't overcome. Whether it is immediate infrastructure problems or planning a future project, we won't simply answer your questions. We become a part of your team to help you complete the mission. Our solutions consider the interests of your business and the combined expertise of the industry, as our staff is made up of more than a dozen experts in different areas who share decades of field-tested experience and knowledge with you.